Okay, hello again Year 9. So you should have your books out, and today's title is Metals and Oxygen. So first of all, we're just going to do a quick recap from what we learned about in the last lesson, which was all about metals and acids. So if I've got two different test tubes here, and I'm going to put a piece of metal in both of them, what observation would I expect to see? So think about what happens in the reaction between a metal and an acid. What do you make? And therefore, what observation would you expect to see? So you can pause it and have a little bit of think about it. Okay, so you should remember from last lesson that metal plus acid gives you salt plus hydrogen. Now we can't see the salt because it's dissolved in solution. However, we can see the hydrogen gas that's produced. So you would see bubbles coming off the metal. That's the observation that you would expect to see, okay? And these are bubbles of hydrogen. Now, let's suppose that I've got two different metals. Okay, so this is my first metal and this is my second metal. What's the difference? Well, we can see that this one over here has got fewer bubbles and this one over here has got more bubbles. And if we say that this is metal A and this is metal B, what conclusion can we draw about metals A and B? Well, they're both doing the same reaction because they're both reacting with the acid and producing these hydrogen gas bubbles, but we can say that B is more reactive than A. Okay, so we see more bubbles, therefore it's more reactive. Now, you also, we won't be able to do it here, but you should also, if you do this reaction, you'll be able to get a small amount of heat. Okay, so there's heat coming out of the reaction. Now, with the more reactive metal, you're going to get more heat. Okay, so over here you have fewer bubbles and you have a small temperature increase. And with the more reactive metal, you're going to have a larger temperature increase. Now, if I have a temperature increase, what kind of a reaction is that? Is that exothermic or is it endothermic? Correct, exothermic. Okay, so these are exothermic reactions. So, with a more reactive metal, we're going to see more bubbles and we're going to see a larger increase in temperature. Okay, right, so moving on to today, so we're going to learn about metals and oxygen first. All right, so we're going to do the reaction of magnesium plus oxygen. Okay, now whenever you react a metal with oxygen, okay, so this is, you'd be combusting this in air. Okay, so you might have an experimental setup that looks like this. You'd have a Bunsen burner. All right, and this would be the flame on your Bunsen burner. And then you would hold a bit of magnesium. So that's magnesium there. And it would burn. And magnesium burns with a really, really bright light. All right, and then once you've burnt it, you're left with this white powder. So you're left with a white powder called magnesium oxide. All right, so what we've got is, we've got magnesium, which is the metal, plus our oxygen, which is a gas, and then we make magnesium oxide, which is a white powder. Okay, so what we can do now is we can write an equation, a symbol equation. So magnesium is Mg, and because it's a metal, it's a solid. So we're going to add here, in brackets, S for solid. And then that's burning in oxygen. Now the formula for oxygen, remember, is O2. And oxygen is a gas, so we're going to put that, a G, in the brackets next to that. And we're making magnesium oxide. Now the formula for magnesium oxide is MgO. So we have one atom of magnesium and we have one atom of oxygen. Okay, and that's a white powder. So is that going to be a solid or a gas? Yeah, it's going to be a solid. Okay, now that equation isn't balanced. So pause the video now and have a go at balancing it yourself. Okay, so you should have got, well, there are two oxygens here. So I'm going to need to have two oxygens here. So I need to put a big 2 in front of there. But that means that I've got two magnesiums. So I need to put 2 over here. And there is your balanced equation. Okay, right, let's do another one. So if we were to do the reaction of sodium with oxygen, remember, like when we did metals with acids, they all react in roughly the same way. Now some might be more reactive, some might be less reactive, but they're all doing the same type of reaction. So if I burn magnesium in oxygen and I get magnesium oxide, if I burn sodium in oxygen, I'm going to get, surprise, surprise, sodium oxide. Okay, now let's do the same again. So we have the formula for sodium is Na, and that's a solid. The formula for oxygen is O2, and that's a gas. Now, this is where you need to be careful. So the formula for magnesium oxide was MgO. However, the formula for sodium oxide is Na2O. Okay, you see the difference. So now there are 2 atoms of sodium and 1 atom of oxygen. So all these metal oxides, these are metal oxides, metal oxide, metal oxide. They've all got different formulas, so you need to be careful when you're writing these out. All right, now you have a go at balancing that one, so pause it and have a go. Okay, so you should have got, if you've got 1 sodium here, and you've got 2 oxygens here, that will give us 2 sodiums and 1 oxygen, like that. So if I've got, let me see, I've got 2 sodiums here, so I'm going to need another sodium here, and I've got 2 oxygens here, and I've only got 1 oxygen here, so I'm going to need another one of these. Now, so now my oxygens, I've got 1, 2, 1, 2, that's fine. 1, 2, 3, 4 sodiums, 1, 2, so I need another 2 sodiums. Okay, so I'll just check it. On the left hand side, I've got 1, 2, 3, 4 sodiums, 1, 2, 3, 4 sodiums, and I've got 1, 2 oxygens, 1, 2 oxygens. Okay, so it's all balanced. 1, 2, 3, 4, so that's a 4, that's a 1, leave it there, and that's a 2. Okay, excellent. Now, just as a reminder, why do we need to balance these equations? Okay, so we need to balance these equations for the conservation of mass. Okay, so you need to remember that the conservation of mass tells us that atoms cannot be created or destroyed. So I can't have 4 sodiums here and then only have 3 sodiums over here. That wouldn't make any sense. Likewise, I can't have 2 oxygens here and then 5 oxygens over here. So on both sides, it needs to be the same. All right, so mass stays the same. During a chemical reaction. probably a good idea to put that on a flashcard. Do that in a bit. Okay, so finally we need to look at the comparing the reactions of metals. So if we were to look at magnesium, so magnesium reacts vigorously with acid. So vigorous just means it reacts quite strongly. There'll be a lot of bubbles, a lot of hydrogen coming off. It's really obvious that a reaction is happening. However, if you were to put some gold, it just doesn't react with acid. Which is good if you think about it, because if you've got a piece of jewellery, a gold ring or a gold necklace, you don't want it reacting with everything, do you? And on the other hand, you're not going to make any jewellery out of something that's very reactive. Okay, and magnesium burns in oxygen, whereas gold doesn't burn in oxygen. So we use these observations now to make a judgment about the metal. So we can call magnesium a reactive metal. And we can call gold an unreactive metal. Now you might be used to thinking about all metals being unreactive. Okay, so there's lots of things in your house, there's lots of things if you look around your room now that are made of metal, and you don't want them reacting, so you don't want your radiator reacting with the air. So those are unreactive metals. However, there are a lot of reactive metals as well, which we're learning about. Okay, so that's it for this video. So there's probably a good idea now if you could make 2 flashcards, I think. So the first one, we can have metal plus oxygen. So you should already have your metal plus acid from the last one. So your metal plus oxygen is going to give you a metal oxide. And then on the second flashcard, you want to have the definition for the conservation of mass. Okay, and so on the reverse side of your conservation of mass flashcard, you're going to want to write down these 2 definitions here. Okay, so make sure you've got all that in your book. You can go back and pause it at each point to make sure that you've got all those notes in your book. Well done.